Good morning to all of you. I Prashant Kumar, Assistant Professor in Mechanical Engineering Department. Today we all are here to discuss a topic. Today's topic is GVF, that is gradually varied flow, which comes under the subject Hydraulics Engineering, BTech 4 Civil Engineering. These are the list of contents that we will discuss today. The contents are gradually varied flow, that is GVF. Second one is equation of GVF, that is variation of water depth along bottom of channel. The third one is some results of slope of free water surface, and the fourth one is numerical problems that we will solve today. The whole lecture is divided into two parts. In the first part we will discuss the above two topics, and in the second part we will discuss the last two topics. Okay. Now, what do you mean by gradually varied flow? Gradually varied flow क्या होता है? Gradually varied flow is basically a part of non-uniform flow. As we have discussed earlier, non-uniform flow are basically of three types: GVF, RVF, and SVF. Now, GVF is defined as if the depth of flow in a channel changes gradually over a long length of channel, then the flow is said to be GVF. For example, flood flow. मतलब क्या हुआ? It can be understood by the help of this diagram. Suppose there is the velocity, flow of velocity V. Okay, and this one is the section. Before this one, all the flows comes under the category of uniform flow, and after that it consists of non-uniform flow. Non-uniform flow basically are of three types, as we have discussed. Only two of them are important, that is GVF and RVF. RVF में the depth of flow changes suddenly, and in GVF the depth of flow changes very gradually along the length of channel. Okay, and in the next slide we will discuss the prismatic channels. Okay, in prismatic channels means if the cross section of the channel is uniform throughout its length, then the bottom slope is called constant, and the bottom slope is constant, it is called prismatic channels. Okay, what are the key features? Key features are: the first one is uniform channel, has uniform cross section, bottom slope is also constant. It can be a various shape like triangular, rectangular, parabolic, trapezoidal, or circular. And for example, artificial channels comes under the prismatic channels. Okay, we are learning this because we will discuss this one also in the equation of GVF. Okay, now non-prismatic means if the cross section changes, okay, and the bottom of the slope is also not constant, then it is called non-prismatic. What are the key features? Key features are since non-uniform channels have the not should not have the same cross section, it has the various bottom slope, that is the bottom slope changes, and the example, that is the natural channels, are called non-prismatic channels. Now in the next slide you see that the first one shows the prismatic channel and this one shows the non-prismatic channels. Okay, ये prismatic channels हो गया और ये नॉन प्रिज्मेटिक चैनल्स है. यहाँ देखो क्रॉस सेक्शन चेंजिंग, बेड ऑफ द स्लोप इज चेंजिंग, whereas it remains constant in prismatic channels. Okay, now we will discuss the equation of GVF. Equation of GVF means before the derivation we will assume some assumptions, like the first one is bed of slope is small, the second one is flow is steady, oscillative effect is negligible, energy correction factor is unity. Formula like Cheji formula, Manning formula are also applicable to GVF for determining the slope of the energy line, and the last one is channel prismatic, as we have discussed earlier. Now what do you mean by energy correction factor? As energy correction factors are also known as kinetic energy coefficient, or you can say kinetic energy correction factor. It is denoted by alpha. It means suppose in the Bernoulli's theorem we assume that the velocity at both the ends, or you can say at the two sections 1 and 2 will be uniform, but in practical situation it is not possible. So to remove this one we will use a factor like alpha. Okay, now you can define as alpha the ratio of the total kinetic energy in terms of actual velocity to the total kinetic energy in terms of average velocity. For example, in case of laminar flow, laminar flow केस में the value of alpha will be 2, and in case of turbulent flow the value lies between 1.04 to 1.11. Okay. Now before the derivation of GVF, we will consider a rectangular channel. That is, consider a rectangular channel having GVF. Let Z क्या है, height of bottom of channel, H क्या है, depth of flow, IB will be the slope of channel bed, I slope of energy line, and B width of channel. Now we will discuss by the help of this diagram. Suppose this one is the diagram. Suppose this is the datum line, this is the bottom, this is the channel. Okay, the depth of the channel is denoted by H. The Z is the distance, or you can the vertical height from the datum level, and V square upon 2G is the kinetic energy. IE is the energy line का slope है, that is the slope of energy line, and IB is the slope of the battle channel. So according to Bernoulli's theorem, the total energy will be shown by the equation 1, that is Z plus H plus V square upon 2G. Z potential, H datum head, potential head, and kinetic energy head. Now if we differentiate the E in terms of X, we will get the another equation denoted by 2. Now d by dx in terms of V square upon 2G will be, as we know that discharge equal to area into velocity, therefore velocity is equal to discharge upon area, that is the multiplication of width and height of channel. Now we will derive an equation denoted by equation number 3. Okay. Now in the next slide, now putting the value of equation 3 in equation 2, that is d by dx is equal to dz by dx plus dh by dx 1 minus v square upon 2g, denoted by equation number 4, where de by dx is the slope of energy line denoted by negative sign of IE suffix में E, and dz by dx denoted by slope of bed of channel IB. Now put the values of dE by dx and dz by dx in equation number 4. We will get another equation in the form of dh by dx is equal to IB minus IE upon 1 minus Fe का whole square, where Fe denotes the Froude number, that is the ratio of velocity upon square root of the multiplication of acceleration due to gravity G and depth of flow H, that is F is equal to V upon square root of GH. Now where dH by dx denotes, or you can say shows, the variation of water depth along the bottom of channel, where H is the depth of flow and X is the distance measured along the bottom of channel. Okay, dH by dx is also called slope of free water surface, that will derived. Okay, now the final value of dH by dx will be IB minus IE upon 1 minus Fe का whole square. Okay, so I think it is clear to all. So thanks and have a nice day. The next topic we will discuss in the next video lecture. Okay, so thanks and have a nice day.